Hey guys, welcome back to General Chemistry. We're going to talk a little bit more about ionic bonds. So just getting into the details of how this happens, why it happens, and giving you some examples. So ionic bonds, remember, are a metal bound to a non-metal, and electrons are going to be transferred. So first thing you need to start doing is start identifying what types of elements are present and what's going to happen to their electrons. So in an ionic bond, what's going to happen is a metal and a non-metal are going to come together. They're going to make an agreement. Our poster child for ionic bonding is sodium chloride. So let's first prove to ourselves that sodium chloride is an ionic bond. So sodium is in the first group on the periodic table. That is most certainly a metal. And then chlorine is over in the 17th or 7A group, those halogens, and that is in the non-metal category. So sodiums are metal, chlorines are non-metal. They come together and they form sodium chloride. Shouldn't be surprising to you. This is table salt, right? And it quite often is the poster child. It's the one we're going to use an example. So how does it come together? Why does it form the way it forms? Okay. So let's break down sodium and chlorine here. Okay. So sodium, remember, has that one valence electron. Okay. That one valence electron is not good. We want 8 valence electrons. That's what we're trying to have. So sodium, remember, he could go out and he could steal 7 valence electrons, or he could get rid of his 1 valence electron, maybe give it to somebody else, and he would go down in energy level, but that energy level would be full, right? So he would be happy. So when sodium gives up that 1 valence electron, what happens? Okay, so I'm going to do this calculation once on this slide for sodium for chlorine, and then you'll never see me do it again, but I think it's a very good explanation. So let's look at sodium. Sodium has how many protons? Yeah, it's got 11 protons, 11 positively charged particles. I know that because it's the 11th element. When sodium is just that neutral element, how many electrons does he have? He has the same number of electrons, right? Oops. So 11 negatively charged particles. So if I have 11 positively charged particles, 11 negatively charged particles, they're going to balance out. And I'm going to be neutral, no net charge. But to gain stability, sodium is going to give up or give away one of his electrons, right? So when sodium says goodbye electron, he gives it away. Now how many electrons is he going to have? Yeah, it's 10, right? He gave one away. Well, now there's an imbalance in the positive and negatively charged particles. So when sodium gives up one of his electrons, he's got 11 positive particles, 10 negative particles. That's going to leave him with a net positive charge. So he's going to be a positively charged ion. Okay. Let's look at chlorine. So chlorine. How many valence electrons does chlorine have? Yeah, he's got 7. Chlorine also wants 8 valence electrons. That would make him happy. So chlorine is going to go out and he's going to try to steal 1 electron. That's going to be his job. Okay, so let's look at what happens when he does that. So originally, before anything happens, chlorine is our 17th element. So chlorine has 17 positively charged particles, 17 protons, right? And we're going to assume that right now he's a neutral atom. So he also has 17 negatively charged particles. He has 17 electrons. But chlorine is not stable or happy with 17. He's going to go out and he's going to try to steal one electron from somebody else. Oh, here's this electron just kind of floating around. So he's going to say, thank you very much. I will take that. So when he does that, now how many electrons is he going to have? He just added one to the mix. Now he has 18 electrons. We got an imbalance again, right? 17 positively charged particles, 18 negatively charged particles. That's going to give me an overall net of a -1, a negative value. He becomes a negatively charged ion. Okay. So with this transfer of an electron, we now have 2 particles that have a charge. But conveniently, one is positively charged and one is negatively charged. Not a coincidence. So here's the big picture. When those 2 particles form ions, of course, the positive is going to be attracted to the negative. And when this happens over and over again, what we're going to see is we're going to see the positives and negatives line up. Positive sodium, negative chlorine, positive sodium, negative chlorine, negative chlorine, positive sodium, negative chlorine, positive sodium, so on and so forth. So those positive and negatively charged particles are going to come together, and that's what holds an ionic bond. The fancy pants word is electrostatic attraction. Electrostatic attraction is just fancy terminology for positives attracted to negative. Why? Why go through all of this trouble? Well, let me give you the reason. Salt, sodium chloride, pretty stable molecule. We all ingest probably way too much of it on a daily basis, right? But let's look at the 2 elements before this magical chemistry happened. So here is neutral elemental sodium. So this is before anything has happened. It's got 11 protons, 11 electrons. Elemental sodium is a metal. It is an incredibly reactive metal, super, super unstable. If you would like to do this, I recommend it. Google sodium in water or sodium in a pond, and you will see just how unstable it is, and you will see just how dramatically it will react with water. Okay? Come over here to chlorine gas. Here is elemental chlorine gas. Before anything has happened, 17 protons, 17 electrons, neutral. Chlorine gas is incredibly dangerous. Chlorine gas is used in the sterilization of surgical tools. So it will react with anything and everything biological and annihilate it. Chlorine gas was also used to sterilize humans. So chlorine gas has been used in gas chambers and used to kill humans as well. So very, very unstable, very, very dangerous substance. But we've got super reactive, super unstable reactive. They transfer an electron. Sodium gives one away. Chlorine takes it. Stability is gained. And we get this molecule. Stable, safe, friendly sodium chloride molecule. Something that we can ingest and we don't have to worry about it exploding in the stomach, or we don't have to worry about it sterilizing our insides. Sodium chloride is incredibly stable. So the whole purpose of this exercise, the whole story here is stabilization. Transfer an electron, gain stability, and we have a molecule that is stable. that is it for your introduction. After this, we'll start talking about and predicting what sorts of ions form. I hope you guys found this helpful.